this is where I finished the last episode. Without wasting your time on a plain talk, let's continue the lesson. As I still have to talk about another event which for me was even more significant than the magnetopore's reversal. It happened almost exactly 1 year earlier and caused one of the biggest disasters of this century. If you notice already the timestamp on the SWMF simulation, you should know already what I'm talking about. If this date is somehow totally unknown for you, this is the exact time of the Great Japan Earthquake. Magnetopore's reversal from 2012 caused a lot of discussion in the Space Weather Society, but it was almost completely unheard by common people. But try to find someone who don't know anything about the Japan earthquake and the huge tsunami waves which followed it. Good luck. In my case, this event was a kind of trigger, and when I saw the news, a huge bell started to ring loudly in my subconsciousness. There is no coincidence in my life, and when on the same day I've heard the information about the sun which started to wake up from the calm period of solar minimum, I've said loudly to myself, it has begun. At this time I didn't know about the existence of ISWA and SWMF monitors. It was 2 years later when I started to learn about space weather, and it took me 1 more year to get the idea of checking the SWMF simulation from the time of quake. And I was amazed. It surprised me even more that until today I'm still the only one who figured out something such obvious. I couldn't find anyone who tried to research this data. But maybe it's why those readings were not censored by NASA and you can check them by yourself on ISWA. Maybe some of you still remember that I've discussed the SWMF simulation results in one of my movies. Actually there were 2 parts, called Planet X Nibiru Clash of the Gods, what was the real cause of 11 March 11 Japan 9.0 earthquake. Maybe it's because of the title that there is only around 1000 views, and most of you didn't watch it. If so, check out those readings. They are quite spectacular, don't you think? Besides, the time of backside blow seems to match exactly with the time of quake. Without any doubts, this is one of the best evidences, if not the best one, of a rogue force which affects our planet. I'm still very proud of this discovery, which clearly proves that space weather activity can be blamed for some of the greatest disasters on Earth. However, SWMF is only a simulation, nothing more than a guess of a possible magnetosphere behavior in response to actual recordings of solar wind parameters. Without some kind of confirmation, those images don't have any scientific value. And this is exactly why I've made another attempt to deal with the data which was recorded in this period of time. And now I'm armed with fresh knowledge and new sources of data. This time I hope to clarify all possible doubts as for the reliability of SWMF simulation results. During this period of time, space weather activity was pretty high. Between March 10 and 12 we can point out 3 separate events. First one, marked with green arrows, took place almost exactly 1 day before the earthquake. Rapid jump of plasma velocity connected with just as rapid increase of density suggests that it was probably a CME, weak one, as solar wind speed grew only to around 350 km per second. Event marked with red arrows, which was recorded in the evening of March 11, started once more as an increase of plasma density, but it didn't affect the velocity too much. However, couple hours later, when density dropped almost to zero, solar wind started to gain speed and reached more than 500 km per second. This allows me to identify this event as a coronal hole stream. Of course, the most interesting activity took place during the time of earthquake. Event, which is marked with blue arrows, took place in the time between 2 typical space weather activities. ACE recorded it as a visible increase of plasma density, what was connected with small IMF instabilities. Problem is that obviously it didn't have any effect on the solar wind velocity. It seems that the disturbances of geostationary environment were stronger than during the other two space weather events, although there is nothing what could explain it. But the biggest problem is that all those readings don't fit to any description of known solar activity. Just like in the case of 2012 magnetopulse reversal, there was a proton event during this time. I have no clue if it has anything to do with magnetosphere disturbances, so I mention it just in case. I've checked Enlil CME predictions to see if an impact was expected for this time. It seems that on some of simulations there was one indeed. But according to other ones, it was supposed to miss Earth completely. Okay, now let's move to the data from Timmy's mission. Here things get interesting. First of all, during this period of time, Moon was far beyond the magnetosphere. It means that data recorded by P1 and P2 crafts wasn't influenced by Earth's magnetic field. Very important is the fact that during March 2011, lunar satellites were still on their way to the Moon. In this stage of mission, both crafts were moving parallel to the celestial body. It was couple months later when they entered the lunar orbit. But let's move to the data which they recorded. It seems that during the day of March 11, Earth was passing through a wave of energetic particles. Just as I said before, I have no idea what kind of space weather activity it was. During the time between two common events, magnetic field became suddenly stable. BZ started to dominate in the IMF, reaching -10 nanoteslas during the initial impact of this unknown wave. This explains probably some of the geomagnetic disturbances recorded on Earth. However, the arrival of frontal density wave from incoming coronal hole stream caused much stronger instabilities of magnetic fields, both in space and on Earth. But this was just the introduction to much more interesting things which were recorded by the satellites during the hours around the time of earthquake. On the charts from P1 craft we can see some strange data corruption around 4 UTC. Soon after, almost exactly at the time of quake, some strange disturbance was recorded by the P2 satellite. On the plasma velocity graph, marked with the red arrow, there is a sudden spike. Vx, which is the velocity along the x-dimensional axis, fell instantly almost to zero, and Vy started to dominate. This gust of solar wind came from the east side of magnetosphere. Almost at the same time, similar rapid change of plasma flow direction was recorded by the P5 craft, which together with P3 and P4 orbits around Earth. Positive value of Vx component means that it was a backside gust of plasma. Now let's look at the data recorded by GOES satellites in the geostationary environment. It seems that the unknown event caused much more instabilities of magnetosphere than the coronal hole stream frontal wave impact, despite the fact that during the second activity AE index was much higher. Couple hours before the quake, GOES satellites recorded a massive outflow of plasma. Here we can see spectral images of electrons from 3 satellites, P5 on top, P1 middle one and P2 bottom one. Spike, which I've marked with arrow, was recorded almost exactly at the time of quake. But data from the lunar crafts is much more interesting. This unknown wave seems to have a clear signature of some kind. It looks like an electromagnetic field and it is quite well defined. By accident it fits in every detail to something what I described as low energy field around 4 years ago. In my pseudoscientific career, low energy field is the most pseudoscientific claim which I've made. Of course, most of my claims was pseudoscientific, and most of them was already confirmed by science. Not so long ago, science admitted the existence of Planet 9. The last thing which still needs confirmation is the electromagnetic influence of Planet 9 on Earth and the solar system. If NASA or other space agency would have the balls to admit it, my pseudoscientific model wouldn't be pseudoscientific anymore. As I said, I'm not a professional scientist. My opinion doesn't matter. I treat plasma physics as a hobby. Just for fun, I've made a model which explains how space weather affects the climate on Earth, and I started it by describing the low energy field. My entire research began from making this imaginary field the main cause of climate change. Maybe I still didn't beat the flat earthers, but I'm close to. However, while you won't find a single picture of the flat Earth edge, I can show you the picture of low energy field. Black arrows point out something what looks like plasma sphere. Corrupted data on P1 recordings is placed right where the central body is supposed to be. The field is visibly deformed by the pressure of solar wind, exactly as you would expect. Outflows of hot solar protons from the environment and inflows of cold particles from low energy field. This is how my pseudoscientific model works, and now it seems to be confirmed by absolutely scientific data. Where is the border between my sick imagination and the reality? But enough of this plain talk, back to the data. It's time to go 3D. This black hole of the missing data from P1 satellite will be a good starting point, as it points out almost the exact time of Japan earthquake. Take a last look on the data from ACE satellite. Because I couldn't load those recordings in 3D view CDPP. Japan earthquake took place soon after the impact of unknown wave of plasma. This is exactly the same data hole in the P1 recordings which I pointed out couple seconds ago. Those vectors represent the velocity of plasma, red and long vectors for high values, violet and short for small velocity. This is the plasma density. We can see here all three events with the unknown activity in the middle. Let's leave the rest for now and watch the animation. Damn, I love science in 3D. Let's look closer at the possible CME impact on March 10. Let's compare the readings from three different satellites. Geotail with Themis P1 and P5. This spectral image was recorded by Geotail. And those vectors represent the magnetic field values from this satellite. Those are plasma velocity vectors from Themis P5 recording. I've explained the data from Themis P1 before, so here we go. And now a close-up on the inner magnetosphere. Look how the density of plasma dropped suddenly just after the initial impact of CME. At the same time, the magnitude of magnetic field started to grow. Outflow of plasma from plasmasphere was the first reaction of magnetosphere to the incoming CME wave. After magnetic reconnection with the CME plasma cloud, particles trapped in the plasma sphere had to be discharged to allow the inflow of plasma from the CME. Soon after the discharge, magnetic field changes orientation on geotail recordings and particles start to fill the inner magnetosphere, what is visible as rapid increase of plasma velocity on TMIS P5 readings. Because I still can't find the plasma velocity recorded as vectors in the geotail databank, I am not capable to tell if this event was connected with inflow or outflow of plasma. But I can figure it out by using the data recorded by GOES satellites. On this chart, it isn't too hard to notice the plasma outflow during the initial CME impact, but I pointed it out anyway. This is what GOES satellites recorded in the time when the funny plasma foam appeared on geotail spectral image. Visible increase of energetic particles allows me to guess that it was an inflow. Disturbance, which was recorded in the night of March 10, took place during the arrival of plasma wave, which forwarded the unknown space weather activity from March 11. Look what happened with the spectral data from geotail when the second density wave appeared on TMIS P1 recordings. A big black area appeared on the image. Data from this period of time is missing. And soon after, missing data appears as well on TMIS P1 readings. "15 minutes later, the ground started to shake in Japan. Let's take a last look at the readings recorded during the day before the earthquake. This time I displayed spectral image of electrons, not ions. And now look what was recorded during the exact time of earthquake. This stream of electrons appeared on the geotail readings together with the orange plasma velocity vector on TMIS P5 recordings. Those particles were injected deep into Earth's magnetic field right at the time of quake. Coincidence? Maybe, but by another coincidence, more than 3 years ago, I've identified those particles as electrons at 200 kiloelectron volts. Those readings were recorded by GOES satellites in the morning of March 11. We can see here a massive outflow of plasma, which started just after first UTC. But at the time of quake, inflows of particles started to appear on those graphs. More than 3 years ago, I've made a claim that the Japan earthquake was actually a reaction of our planet to the first contact with low energy particles, which were injected into our magnetic field by low energy field. Today, I can only sustain everything what I said before. Now I want to add the data from Ampere site, which makes a nice visualization of geomagnetic field recordings. I pointed out the Japan area. This image is from 40 past 5 UTC, 5 minutes before the quake. 10 minutes later, at 5:50, we can see that geomagnetic field orientation in this region went through a visible shift and vectors started to point into opposite direction. 10 minutes later, there is no sign of this disturbance. It's amazing how nicely all those readings work together. Check out the energy diagram on fog radiation belt simulation. Here we can see the outflow of electrons from Van Allen belts. And this is the stream of particles from the time of quake. And finally, let's move to the ionosphere. There are no doubts that the mysterious space weather event from 11 March 11 caused a serious disturbance of the ionosphere. It caused a visible decrease of electron density. CME impact and coronal hole stream arrival didn't cause any visible disturbances of the ionosphere. It seems that I found another evidence of the magnetopause reversal event from 2012. Check out the readings on SWOSI Tech Monitor. I'm pretty sure that it is not a typical ionospheric activity. But I think that we spent enough time speaking about the events from the past. My plan is to discuss the satellite data recorded during the last 3 or 4 years, but I will make it somewhere in the near future. For now, let's move to more recent activities. I'll begin with a rather common space weather event, a coronal hole stream impact, which took place during the last day of year 2016. Those graphs give us a nice background of the entire story. In the morning of December 31, density of plasma in the solar wind started to grow. Just before the noon, we were hit by a wave of more than 50 particles per cubic centimeter. I pointed it out with the red arrow. It seems that at this time the IMF orientation remained pretty stable, green arrow, and the wave didn't cause any serious geomagnetic instabilities. Of course, like in most of similar cases, increased plasma density is a sign of incoming coronal hole stream frontal wave. Blue arrow marks the time of a sudden density drop and a rapid increase of solar wind velocity, which jumped almost to 500 km per second in the matter of minutes. And this is how the coronal hole stream arrival is supposed to look like. Dense wave of plasma in front, followed by much less dense stream of fast solar wind. During similar events in the past, increased density of plasma was connected mostly with strong and rapid shifts in the IMF orientation, and this was the main cause of geomagnetic instabilities on Earth, but not in this case. During the last day of December 2016, space weather activity wasn't ordinary. Normally, soon after the passage of frontal wave, IMF magnitude is supposed to drop. In the streams of fast solar wind, there is almost no plasma at all. Density drops below 1 particle per cubic centimeter. Magnetic orientation of fast solar wind is rather stable, directed mostly outwards or towards the Sun. BX component is dominating over the other two. If you want to see a nice example of fast solar wind stream, look at the readings behind the blue arrows. Those recordings match perfectly to my description. But now we have a small problem. There are 6 hours between the impact of frontal density wave and the arrival of fast solar wind stream. It seems as well that during this period of time, satellites recorded some kind of space weather activity. Although after the frontal wave passage, density of plasma was greatly decreased, it remained at around 10 particles per cubic centimeter, what still is a pretty high density. And now let's add the fact that the strongest IMF instabilities took place during the unknown event. If I would be asked what kind of space weather event we're dealing with, I would say that it looks like a CME which was somehow injected between the layers of a coronal hole stream. But don't ask me how it was possible. I'm just trying to understand those recordings. Anyway, during the strange activity, IMF orientation was dominated by BX component. while BZ remained unstable. This is probably why the KP index didn't reach more than 4 points. Of course, it doesn't mean that there wasn't no response of geomagnetic field. Actually, magnetic disturbances were pretty strong on Earth. Even if I saw before much stronger geomagnetic disturbances, those ones affected the entire magnetic field of Earth and were recorded by many different stations. Now let's take a look at the data recorded by Timmy's P1 satellite. Here the unknown event becomes visible much better. Red arrow marks the increase of plasma velocity during the unidentified activity, while blue one shows an interplanetary shock when the stream of fast solar wind arrived. Some strange readings were recorded around the last hour of year 2016. Velocity of electrons dropped suddenly almost to zero, but after a couple minutes everything came back to normal state. Sadly, I can't visualize it in the 3D view CDPP, as the data from P1 and P2 crafts is still not available to upload it into the application. Instead, I will show you some other satellite data. Those are the readings recorded by Van Allen satellites. I've marked with red lines the beginning and end of December 31st. Graph on top shows the DST values. The one below shows the KP index. As you can see, according to official data, space weather activity during this time didn't cause a geomagnetic storm. KP index reached only 4 points at the end of the day. But the data recorded by satellites is much more interesting. Those two charts show the amount of high energy electrons. It is clear that the unknown event caused a serious reduction of energetic particles in the magnetosphere. Those two charts are very important. They represent the density of oxygen ions. It seems that during the unknown activity, the outflow of oxygen was greatly increased. But look at the density of electrons at lower energy bands. It seems that while the amount of high energy particles dropped during the event, density of low energy electrons started to grow. It is visible much better on the charts representing particles at lowest energy bands. Whatever was the nature of the unknown activity, it clearly caused the outflow of high energy particles and inflow of low energy electrons. And now let's compare the satellite's recordings to some of the monitors available on ISWA site. Those two graphs show the simulated radiation belt fluxes. As you can probably see, the outflow of energetic particles is visible here as well. But the most spectacular readings can be seen on the fog radiation belt simulation at the lowest energy bands. Check this out. Just like on the Van Allen satellite's recordings, the amount of low energy electrons started to grow after the unknown event. Only here it seems to be quite dramatic. However, here the biggest inflow of particles started on the January 1st, 2017. However, I've looked at the data from satellites and I couldn't find anything similar. Here is a nice comparison of the recordings from Van Allen satellites with the solar wind velocity from ACE. I've marked the last day of December 2016 with an arrow. As you can see, there is no sign of sudden increase in the density of electrons after the unknown event. But according to fog radiation belt simulation, extreme inflows of low energy electrons took place till January 5th, when particles discharges started to occur one after another. To be honest, I don't know how to explain this, however it seems that the discharges started at the time when Earth started to be influenced by a much faster coronal hole stream. During January 5th, velocity of solar wind grew almost to 700 km per second. It seems as well that this day was a beginning of another weird space weather activity. Look at this graph. Since January 5th, ACE satellite started to record some weird spikes of low energy protons. Another unsolved case from the PX files. Maybe Mulder and Scully will explain this phenomenon in the next episode. But this was just the beginning of true weirdness, which happened 2 days later, in the morning of January 7th. Some time ago, I've uploaded on YouTube a recording of some strange magnetosphere anomalies. They looked almost exactly like this one. And by some weird coincidence, right at the same time, Spaceship Earth, a network of stations detecting cosmic rays, started to record some kind of disturbances. On other monitors from the Bartle site, there are data gaps in the same period of time. What tells me that those readings are not caused by errors. And there's still more. I won't lie by telling that there is a clear connection between all those disturbances, but during the time of their occurrence, some very interesting anomalies of air circulation took place above Europe. Some of you might still remember a couple of my movies in which I've explained how magnetic reconnection at lower geographic latitudes affect the air currents. For those who don't know what I'm talking about, in my model, condition and shape of polar vortex depends on the open magnetospheric field lines. During magnetic reconnections triggered by BX and BY components of the IMF, open field lines are being pulled down towards the equator, and the air masses aligned with those field lines follow the same path. Imagine a giant magnetic octopus which uses one of its tentacles to reach the tasty, warm and humid air masses above the equator. Now I would like to show you how this process looks like in real life. For those who didn't notice, I've marked the magnetic tentacle which covered almost half of the continent and reached to Mediterranean Sea. Look what happened next. According to my model, this is the area where an open magnetospheric field line sticks out from the surface, allowing the exchange of energy between Earth and the IMF. Check out how this process affected the temperature near the surface. If you've heard about the extreme cold wave in Europe, now you know its cause. Look how far to the south the magnetic octopus managed to reach with its tentacle. Luckily, the connection was cut out 1 week later. It seems that I have found another piece of interesting data regarding the strange event from December 31st. Those solar wind parameters were recorded by the wind satellite. Interplanetary shocks between the unknown activity and the coronal hole stream are visible here much better than on the recordings from ACE. But just in case, I've marked them with arrows. Those two graphs show the velocity and density of solar wind plasma. But it's the lower graph which caught my attention. For some unknown reason, this parameter of solar wind is not recorded by ACE satellite. Maybe because this data can be used to prove that planet X, or my low energy field, is already affecting the heliosphere. I think that SWMF simulations would become much more interesting if the input parameters would include the angle at which the solar wind is flowing towards Earth. For example, those two arrows point at two sudden changes in the phi angle of solar wind velocity. 180 degrees mean that particles travel from the Sun to Earth exactly along the x-dimensional axis. When the angle is smaller or bigger, it means that the direction of solar wind flow is tilted to the east or west. According to this graph, the unknown activity caused a rapid shift of the solar wind direction. As almost exactly at noon, the phi angle dropped from 190 to 170 degrees. Then, couple hours later, just before the arrival of fast solar wind stream, the angle shifted even more and fell almost to 160 degrees. This gust of solar wind hit only one side of the magnetosphere. But this was just an introduction to something what might be the missing key in understanding the nature of all those weird disturbances from the end of year 2016 and beginning of January 2017. Look at the 28 days of recordings from wind satellite. It seems that after the first event from December 31st, direction of solar wind flow was messed up for the next couple days, more precisely until January 5th. If this didn't tell you anything, couple minutes ago I pointed out this date while I was showing you the radiation belt simulation on ISWA. Of course, this could be only a coincidence, but I think that it is not. Why? Because it seems that around 2 weeks before the activity on December 31, wind satellite recorded similar shifts of the solar wind flow direction. Because I really like to connect the dots, first thing which I've made was to check the behavior of fog radiation belt monitors during this period of time. And guess what? By a total coincidence, those readings look almost exactly the same as the ones from the beginning of 2017. And because it seems that I've triggered a real outburst of coincidences, data recorded by Van Allen satellites seems to match as well to the disturbances recorded during the last day of 2016. However, during 20th of December, the space weather activity was increased due to a coronal hole stream impact. So I will show you the readings recorded 2 days earlier. At this time, wind recorded similar shifts of solar wind flow angle, but space weather was calm. On those graphs we can see that just like before, this event was connected with an outflow of high energy electrons and protons, while the amount of low energy electrons started to grow. Okay, but the most important question is, can I at last give you some actual explanation of those strange space weather activities? I think that you won't like my answer. The truth is that I can't. Researching all those things is like hunting mythical creatures in a deep and wild forest. There is almost no difference between searching of undeniable proof of Planet X and trying to catch a living Bigfoot. Maybe except my own comfort and safety. Data which I've just presented you is for me like a fresh track, couple giant footprints and some reddish hair which was left on a barely visible path which leads to a watering place. Now all I need to do is to follow those tracks all the way back to the Bigfoot's nest. Or a cave? Of course, I started already to travel deeper in the forest. I've checked the wind recordings from previous months. However, it is far too early to make any claims. I still need to make a lot of additional research before I try to make any serious statements. Just in case, I've ordered my crew to switch off the camera. This part of the job is rather boring, and there is always the possibility that instead of a Bigfoot, I'm chasing an overgrown rabbit. For the end, I would like to show you some strange disturbances recorded on radars during January 26, 2017. And with this animation, I will finish this lesson of fear porn space physics. Class dismissed.